Alright then, I thought I'd make this video whilst my laptop renders the next video out. So what we're doing here is proof by deduction, and this is the last of our proof for the first year of A-level maths. Just a little thing before we get cracking, I've got my microphone here, and it's held up by a plaster. Let's hope it goes okay. If not, oh dear. Anyway, let's get cracking. Proof by deduction is something that we've kind of already done. This was part of proof by exhaustion, where we were using our algebra skills to take logical steps up to some kind of statement or conclusion that depended on the initial statement. So since we've already done it, I'm going to define this with a naff little diagram, then we'll get straight into a really good example, and then we're going to use proof by deduction to actually prove where the quadratic formula comes from. They actually come from a quadratic, all right? Right, this is a bit of a funny way of describing it. You get some kind of mathematical statement, you follow some algebra steps, these are logical steps to some sort of conclusion. You are taking yourself from here to there, and that is proof by deduction. So we've already been doing it as part of proof by exhaustion, but we've never really done like a solid proof by deduction example. Now a really obvious one is prove that every odd times even number is an even? Yeah, it is. But now we need to prove it. Let's get this question. Okay then, so prove that any odd times even is an even. We could do this via proof by exhaustion by saying, okay, 6 times 3 equals 18. Ding, 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 ding. But that's not actually useful in this situation. So here we use this cheeky little trick where it was kind of like in the proof by exhaustion with the 5k and that lot. What we're going to say is, right, here's our sneaky tip. We're going to say that 2n is an even and 2n plus 1, which is one more than that, is an odd. And that's for all n in the integers, the zintegers. So once we've got that, we're going to stick that into here. I've got so many pens in my hand. And just do 2n times 2n plus 1. But there's a problem here. If we did 2n times 2n plus 1, that means that we're just doing like 6 times 7 or 2 times 3. They're just consecutive odds and evens. So we actually have to change that and do another letter. M is still an integer, but it's a different one to n. So, this is actually going to show that they're actually two different things. So multiply this out. Take out a factor of 2. Now we're going to say let k equal to n m plus n, which means that this is now substituting 2k, which is even, since anything times by 2 is even. So now just finish this off with a little statement. Bada bing, bada boom. That's it. Job done. That was a really simple one. We're going to put that to bed because we're good at that. And now we're going to move on to the quadratic formula. Now, when I was learning the quadratic formula, it really annoyed me because I didn't know where it was from. As soon as I learned where it was from, I liked it. So hopefully this will have the same effect. So we're going to get this as a little question and go from there. This is our question here then. So prove the quadratic formula is a solution to the general equation of a quadratic. So there's two ways of doing this. We could prove it by just putting it into the quadratic and then saying, look, it equals 0. Or we could just derive it. And I like the derivation really, to be honest. And it gives you a lot of understanding from where it comes from. So to do this, you use a little bit of GCSE knowledge, which is just completing the square. So we take our general form for the quadratic, ax squared plus bx plus c. Then you're going to divide by a. What that does is put your coefficient on x squared equal to 1. And I'm pretty sure it's raining outside. Anyway, once you do this, you can do completing the square on here. So to do that, we're going to do half of this bit, which is on the x coefficient. No. Half of the coefficient, which is on x. Get the wording right. Square that. And then once you've squared it, you're going to add on the c over a from before, and then minus off this times itself, which is b squared over 4a squared. And that's all equal to 0 still, because that's part of the initial condition. Once we've got this, we're just going to start rearranging to get x on its own. So skip a line. Yeah, the rain's coming down heavy now. Nighttime rain. So we've got these two fractions by themselves now. Now, these are over different denominators. That's not very nice, the two different fractions, so we're going to put them over the same denominator by putting c as over 4a squared. So we're going to times top and bottom by 4a. So you see there? We've got them both over the same fraction, so now we can just kind of join that up and put it over the same one. I'll do that in the next step. So now it's starting to look really familiar. On the top we've got the discriminant. So we're going to undo this square. So we're going to square root the top. 4a squared is 2 squares. So we can just take that when we square root to 2a. Isn't that nice? So let's do that next step. We don't need this anymore. I'm worried that I'm going to run out of space. I'm cramming it a little bit now. So we've got x plus b over 2a equals, now we've got plus or minus the square root of b squared minus 4ac. See, it has to be plus or minus because we're square rooting. If we only had one, either plus it or minus it, then we're only going to get one solution. Because it's a quadratic, you're going to have two solutions. It goes like that on the graph. So the maximum it can have is 2 solutions. The minimum it can have is none. Well, no real solutions anyway. So now we're just going to take that over to the other side. Same denominator, you'll notice. So we can just minus it off. So you get and that's the end. That's it. Now you don't get this in your formula book for A level, so you do have to remember that. If you don't remember it correctly, ooh, you're going to make this a little bit difficult. Yeah? But if you do remember it, then it's going to make your life a lot easier. Some calculators like your class whiz, like where's Pam? Don't have her. Your class whiz can actually do this on it. But you don't rely on that, because you won't get those marks in an exam for actually showing method. We'll give you answer marks, so it's good for checking answers, but you have to do this kind of stuff, right? So, where's red pen? Here's your summary. This, good. This is a great tip. And then this. not in the formula book. And that is it for first year proof. That's it. I'm not going to do any jazzy bits at the end of this video. We're just going to end it. And then we're going to go into indices and surds and into geometry in the land of good math. All right? Yeah? See you later then.